Hi everyone. Today we would like to present our project Beverage Spending Behavior of University Students. Our study focuses on understanding how university students spend money on their beverages, including their daily life habits, or their preferences and financial behavior. So why did we choose this topic? First, beverage spending is actually a significant part of daily life, and the expense many students buy a drinks like a coffee, tea, or soft drink almost every day. And the second, these purchasing habits reflect both lifestyle and the financial behavior. For example, how often students buy drinks, what they prefer, and how much they spend. Finally, by studying this topic, we can gain useful insights into student consumption patterns and how understanding how students manage their money in everyday life. The main goal of our research are the first, to analyze beverage spending behavior using statistical methods, and second, to identify patterns in students' spending preferences and consumption habits. In simple terms, we want to understand what students drink, how often they drink, and how much they spend, and then use statistics to explain these behaviors. So next, let's talk about how we collected our data. We used an online survey created with the Google Forms. The survey included 17 questions and took about 3 to 5 minutes to complete. Our responses were anonymous to ensure honest answers. In total, we collected data from 60 university students, which we used as our sample for analysis.
Let's start with the age distribution of our response. As you can see, most students are between 22 and 23 years old, with 23 respond in this group. The distribution looks approximately normal, with very few students at extreme age. Only 5 students aged 18 to 19, and just 2 students aged 26 to 27. Next is monthly income in baht. Here is the distribution is right skewed. Most students earn between 5,000 and 15,000 baht per month. However, a few high income students above 20,000 baht create outlier. Because of this skew, the median is a better measure of typical income than the mean. Now let's look at monthly beverage spending. The median is 1,500 baht, which represent typical spending, while the mean is higher at 2,143 baht. Pull up by a few high spenders, the distribution is also right skewed, with most students spending below 2,000 baht per month and only a few spending very high amount. Finally, sleep. Finally, sleep hour, most students sleep between 6 and 7 hours per night, and the distribution is approximately normal. Very few students sleep less than 5 hours and more than 8 hours. Overall, the average sleep duration is below 7 hours, which suggests that many students may not be getting enough rest.
Next, I will present the correlation analysis of our selected variable pair. For the first pair, which compare daily beverage volume in milliliters and yesterday beverage spending in baht, our expectation was that students who drink more beverages would tend to spend more money. From the scatter plot, we can see a positive trend, but the points are still quite spread out. The correlation coefficient is around 0.33, which indicates a weak to weak moderate positive relationship. This means that as beverage volume increases, spendings tend to increase slightly as well. However, the relationship is not strong, so the volume alone does not fully explain spending behavior. Next is the pair 2 that compare the monthly income and monthly beverage spending. Our expectation was that students with higher income would spend more on beverages. From scatterplot, we can observe a positive relationship. In general, students with a higher income tend to spend more on beverages per month. However, the points are not tightly clustered around a line, so the relationship is only moderate or weak to moderate, not very strong. This suggests that income does influence spending, but it is not the only factor. Personal preference, frequency of buying drink, and lifestyle also affect beverage spending. Next is the third pair that examine food beverage timing after waking and sleep hours. Our expectation was that students who sleep less might buy their first beverage earlier after waking. From the scatter plot, the trend appears slightly negative. This means that students with a fewer hours of sleep may tend to buy their first beverage a bit earlier, but the correlation is very weak, so the relationship is not strong enough to make a strong conclusion. So while sleep may have some effect on beverage timing, many other factors could also be involved, such as class schedule, morning routine, or personal habit. And finally, the fourth pair that compare the coffee cups per week and average spending per purchase. Our expectation was that students who drink coffee more frequently may spend more per purchase. From the scatter plot, we can see a weak positive relationship. This means that students who consume more coffee per week tend to spend slightly more per purchase. However, this relationship is still weak, so coffee consumption frequency does not strongly determine spending per purchase. This may be because some students drink coffee often but choose cheaper option, while others drink less often but buy premium beverages.
So this section introduces our hypothesis testing. We test whether students' actual behavior matches our assumptions about the population mean. Using a z-test at a 0.05 significance level, we evaluate 15 variables. Now I'll walk through a few key examples. This table shows the full results of all 15 hypothesis tests. Each row represents one variable with its taste statistic and decision. Most variables fall within the acceptance region, so we fail to reject the null hypothesis. Only a few show significant differences. I'll now go through some examples. First is the monthly beverage spending. The sample mean is about 2,143 baht, slightly higher than the assumed 2,000 baht. However, the test statistic does not exceed the critical value, so we fail to reject the null hypothesis. This means spending is not significantly different from expectations. The next is cups of coffee per week. The sample mean is about 3.12 cups, very close to the assumed value of 3. Since this result falls within the acceptance region, we fail to reject the null hypothesis, so coffee consumption aligns with expectations. Next is soft drinks and energy drinks per week. The sample mean is about 1.47, lower than the assumed value of 2. Here, the taste statistic exceeds the critical value, so we reject the null hypothesis. This means students consume significantly fewer of these drinks than expected. And next is sleep hours per day. The sample mean is 6.6 hours, below the assumed 7 hours. Since the result falls in the rejection region, we reject the null hypothesis. This shows students are significantly sleep deprived compared to the expectations.
Okay, these sections present the goodness of fit tests using the chi-square method. We use significance level alpha equals 0.01. The purpose is to compare observed frequency from our sample with expected frequency from the theoretical distribution. If the chi-square statistic is greater than the critical value, we reject the null hypothesis. We test two groups of data: nominal data with uniform distribution and numerical data with normal distribution. This right test whether all beverage types are equal preferred. The null hypothesis says each of the 7 beverage categories has the same probabilities with 60 respondents. The expected frequency is 60 divided by 7, or about 8.57 per category. Degrees of freedom equals 7 minus 1, so df equals 6. The critical value at alpha 0.01 is 16.81. Our test statistic is 408.17, which is much higher than 16.81. Therefore, we reject the null hypothesis. This means students do not prefer all beverage types equally. Tea or milk tea is the most popular choice. This slide tests whether test rating from level 1 to 5 are equally likely. The null hypothesis says all 5 levels have the same chance, so the expected frequency is 60 divided by 5, which equals 12 responses per level. Degrees of freedom equal 5 minus 1, so df equals 4. The critical value is 13.28. The test statistic is 290.44, much larger than the critical value, so we reject the null hypothesis. This means students do not rate tests equally across all levels. Most students selected level 5, meaning test is extremely important. This slide summarizes tests of numerical variable. We test whether each variable follows normal distribution. Is has chi-square 4.48, which is below the critical value, so it follows normal distribution. Sleep hours also pass with chi-square 10.07. Year of student pass with 16.65. First beverage timing pass with 6.75. However, monthly income has 1,061.41 and monthly spending has 6,112.31. These values are much larger than critical value, so they are they do not follow normal distribution. This means many financial variables are skewed. For nominal data, both tests rejected the null hypothesis. Preferred beverage type has chi-square 408.17. Test important has chi-square 290.44. Both values are far above the critical value. This shows students have clear preference. They choose some beverage more often and test stronger affect their buying decision. For numerical data, only some variables follow normal distribution, such as age, years of study, sleep hours, and first beverage timing. Most spend and consumption variables do not follow normal distribution. For example, yesterday spending had chi-square 445,938,927.60, which show very high variation. This means many students spend a small amount, while few spend much more because of the light school data. Median is often better than mean. Thank you for listening to our presentation. Our goodness of fit analysis show that students have strong beverage preference and spending behavior is not normally distribution. We hope this study gives useful insights into university student consumption behavior. Thank you so much.